we are not focusing on these algorithms, but you know already one of them, DE-optim, which you use, is such an algorithm. Driven search. And a science developed to set up, to devise these search algorithms, search softwares. And now you have several possibilities. The most used algorithm today is the genetic one. DE-optim is a genetic algorithm. And I'm not going into the details, but there are several variants of them and several techniques. And if you look in R for optimization, you find a lot of different solutions. And there are a lot because, you know, these methods differ for computational requirements and efficiency in the search, because you can easily understand that you may fail. When the search is done in this way, trying to identify the best subregions and then exploring only those subregions, you may fail. You may miss some regions where you have the highest benefit. So basically, people developed several algorithms because they realized that sometimes it's better to use more than one. But indeed, today we can solve optimization problems with like thousands of decision variables. And still, this is a scientific field that is very active. Because think of a situation like the Nile River, where you have a cascade of dams. There are some rivers in the world where you have a cascade of like 50 dams. And then you have to manage all of them by taking into account that when you release water from the upstream dam, you get an inflow downstream. So all these management cannot be done independently. You have to devise, you have to perform an integrated study, which means that you have, for 50 dams, you may have like 500 decision variables, like releases, storage, and environmental flow requirements, a lot of them, and you have a lot of constraints, because you have the upper value of the storage in each dam, the lower value, which you cannot violate, and many others. So basically you put together a benefit equation that includes like 500 decision variables, and then to explore all the possible solutions is really an IT problem that is very relevant. So this is still an active field of research, but basically this is how water resources management is done today. So basically we forgot the analytical methods, and now the efforts are towards artificial intelligence and information technology for finding by chance the best solution. And there are long traditions in that, and there are a lot of people in Asia now focusing on these problems, because in Asia now they are building a lot of dams, and I think I already mentioned to you this recent development. Dams are not built anymore in the Western world. In Europe and the United States, basically, we exhausted all the possibilities, and also we realized that the environmental problems related to building dams, and therefore, this is an activity that slowed down here. But in Asia now they are building a lot of dams because they didn't use this opportunity before. And for instance, the Mekong River the water of the Mekong River was not really exploited much up to now, because they had political tension and wars in the past, and of course during wars you don't build dams. But now they have the opportunity to start very ambitious projects and And therefore in these regions in Asia they are devoting a lot of efforts in studying optimization problems for dam management. They have systems, river systems that are very complicated to manage. So basically these are the two alternatives that you may use when you have to find the optimum of function. I just wanted to close this lecture by saying you one important thing. We implicitly assumed so far that all the behaviors of our problems, and I want to be more specific, the benefit function, the constraints, etc., are exactly known. I didn't speak about uncertainty. You may easily realize that benefit functions are affected by uncertainty because I told you that everything in hydrology and water resources management is uncertain. So the next step is how to account for uncertainty. And this is extremely important because one thing is the decision that you take when everything is defined with certainty. Another thing is the decision that you take when there is uncertainty. It's a different decision because uncertainty means risk. So basically, if you neglect uncertainty, you may take a decision that is not doable in practice. Because, for instance, you get less water in the river than you predicted. Q may be uncertain. And therefore, you need to evaluate not only the decision, but also what happens if the decision cannot be taken in this way. And this is our next step. Before you leave, one thing I wanted to tell you, given that we will finish our lecture at the end of April, more or less, I will tell you shortly which day we will take your opinion on my subject and lectures. And I really would like that you attend that day. So I will tell you before then, well in advance, because I really would like that you attend, because I think that the evaluation by you of the quality of the teaching is extremely important, and I don't want to miss it. So basically I want you attending, and many of you, so because I know that while we move to the end of the subject, then some of you decide maybe not to attend the lectures anymore. I really would like that you make an effort, I tell you well in advance, to get a lot of students that day to make the evaluation. And I will explain you more why it's important and why I am particularly interested in knowing your opinion on this subject and etc. Okay, thank you. Let's meet on Tuesday.